I was just curious, like, what other end use technologies are folks focusing on? Like, the latest I've heard is about Arizona, like a couple of utilities in Arizona using heat pumps with built-in thermal storage, and that's like from I think New Brunswick based company. But yeah, I'm just curious if like something else is on the horizons in terms of like the technology applications for a VPP program.
I have no idea.
I think heat pumps are the hot right now. I don't know what to hear about.
I mean, they are irreplaceable. So yeah, I was just curious if there are other things beyond heat pumps and smart thermostats, so to speak. Yeah.
I mean, there's lots of things, right? Like anything that has electrical load that can be controlled. But I mean, there's endless lists of that. But I think most people are focusing on like actual projects focus on like thermostats. I think heat pump water heaters. I heard some people talking about pool pumps a long time ago, which you don't think about in California because no one has a pool here, but it's a thing in other states. Because they do have a big load and they're summertime products, I think mostly. So there's a there, but I don't know. I'm gonna try to share my screen again. See if I can share. Okay, can you guys see my whole screen?
Yeah.
Okay, so I'm going to show you. No, this was the report, I think. So this is the capacity assessment when you're doing DRAM, and maybe that was, yeah, this is the DRAM spreadsheet. No, this was the RA thing. They're horrible. They're absolutely horrible. Like this is when you're like an innovative DR provider or aggregator. You have to go in this thing, fill these out, and do all the info logs and reporting. No, you have to do this on a yearly and a monthly basis for the IOUs. This is for DRAM, the demand auction mechanism. And then when you're providing RA, this actually looks different than when I did it. They've updated it. But this is when you're providing resource adequacy. I'll share the links when I'm done sharing. But you have to go in and there's like a locational way you organize your data. It's called a sub load aggregation point or SLAP, and it basically you can kind of think about it like counties. And the ones they're showing here are like what they call local counties. There's a bunch of nuances, but really like in my experience in KISO and CPUC, it's all just built on the back of spreadsheets. When you're actually like bidding in and showing your RA supply or your DR for the programs. Um, it's just a bunch of fucking spreadsheets. It's horrible.
You trying to scare us away from this field, or
Well, it's not to scare, but to just show like the reality of what most people regard as one of the most innovative states for DR. You know, it's still very antiquated. I mean, I guess like the financial system, right? That's also built on the back of spreadsheets. But I'll get the link so you can see for yourself what those files look like. But
so? Is it the CPUC who built those spreadsheets, and you have to submit them to PG&E ish, or?
yeah, yeah. So with DRAM, you submit you have those spreadsheets to the IOUs, so PG&E, SCE, SDG&E, and then they do their own reporting for the DR for resource adequacy, which is capacity or however you want to call it. It's like someone buying your ability to perform in a later month. That you do submit to the CPUC, but the supplier doesn't. The buyer submits that. So like I, Kristen, am aggregating DR. I sell it to P2 like a Marin Clean Energy SCCA. Then they go and report that to the CPC. But it's like a hand in hand process. And everyone, any kind of like it's not just DR. I mean, it's DR, but not like people DR only. It's like if you're doing V2G, if you have some sort of solar aggregation, like anyone kind of doing load management does that. And there's lots of ways people have VPPs outside of that, but those are like when you're thinking of like long-term economic products, like that's what most people use those products.
Yeah.
So yeah, just a bunch of spreadsheets. But I'm gonna give you the links. So yeah.
Can you give us a quick background? So are you like, where do you work and what's the context for this? Like, is this like a work project or?
That was a work project. So now I'm at the Department of Energy's Grid Deployment Office, and I'm working on we call it grid modernization and billions of dollars of grants. But previously I was at PowerFlex before this, and then before that I was at Ohm Connect, and Ohm Connect is where I was working in DRAM.
Got it. Thank you.
Mm-hmm.
So, sorry, could you summarize the whole point of the spreadsheets again? Is it to communicate about the resource adequacy to the commission, or is it to the like the vendors or the aggregators?
Both.
Both.
Yeah,
Okay.
it's your reporting mechanism for all these
Okay.
programs, but
That's
it's just
interesting.
to show like it's not this fancy, software or whatever. It's just a spreadsheet that gets uploaded from the suppliers end.
It's reporting, but I mean, like this doesn't probably it's not taken into account for payment and all of that, right? Like the meter is still.
Yeah. Well, for DRAM, the payment is more or less set. You're kind of like whatever you contract, the payment is set, and similar for resource adequacy between you and the buyer payment is set, and then but then there's like a whole market mechanism behind it where you're actually performing for resource adequacy that doesn't exist for DRAM. DRAM is just kind of like I'm selling you one unit, PG&E, you're going to buy that unit at this price, either the same price all year round, but most usually it's like low price in the spring, higher prices in the summer. And then there's the DRAM. I don't know. I know they kept updating the rules when I was working in it. The rules were a bit of a performance expectation, so there could be like payment adjustments on performance, but it was really complicated. That was the way more complicated part. Like after the month ended, you would go back and say, okay, like how do I calculate energy savings or demand response and what wasn't consumed and things like that.
When I see that type of I mean, whenever I see a spreadsheet, I think opportunity because like it can be made way better, right?
I know.
Um,
I know.
Could this have been made better since you left, or is it still being done by this? Do you have like information on that, or
That's
is
the spreadsheet. It's still being done. I kept promising a link.
okay? Yeah.
Yeah, here is. So I was showing PG&Es. They're all pretty similar, but where's the chat here?
Like, I guess do you guys know who's like the big like utility software provider? Like, is Oracle doing this stuff or AutoGrid? They're like, who would be the contractor for the government who would even build this for the government or provide it to them or the utilities?
For the utilities, well, I don't think the utilities want to pay for it yet, so they're not doing the software. But for what else the utilities do, I don't know. I think it's a lot of different.
Because I think from Ben and my perspective, we're trying to build a product and we're like applying to programs and stuff. So we're trying to figure out, okay, what's the missing software piece in this? Can we do something?
Yeah.
And I actually recently looked at this CalC program, which Ben also had looked at, and they had like very specific things that California needs for DERs. And I'm trying to think back, like, was one of these like things on there, or like what they're doing to improve this process, maybe?
Well, there's like maybe a nuance that the DRAM program is technically still a pilot program.
Okay.
And I think that impacted its funding and it's just like its longevity because no one ever really knows if it's going to get extended. But I don't want to take up all the time talking about DRAM. It's a terrible memory. I'm curious if anyone else has cool VPP projects they wanted to talk about. Or if anyone's been following Tesla's work in Texas.
Have they done anything new outside of the free energy at night sort of thing?
They're making a VPP program for like they registered as a retail energy provider or REAP, as some people call it. I don't know why you're not rep.
Right.
It's
Yeah.
REAP. And yeah, they're just they're doing anyone who has their power wall. I don't know if you have to have a car or which I assume the solar panel, but yeah, they're just entering the market as a VPP, and like all VPPs, I think it's a peak load shaving product mostly. It's not like daytime energy, but people are really excited about it, about what's going on in ERCOT with the REAPs. But I don't know that much. That's kind of the extent of what I know. My view shifted to kind of more national scale with my new job. So.
As long as it saves them from the next winter storm, I think it's a success.
Yeah, I haven't heard anything else about it.
Yeah, like in their 4-hour investor presentation, there was only like a small bit on their energy business. So I think they're like still ramping up their energy side, and they're still pretty focused on the cars. Um, and then VPP is just like a small portion of the energy business. Yeah.
Once they have all of their home batteries and cars everywhere, just need to flip a switch in there.
Yeah. Because the software part is easy, or flipping the switch part is easy. They're just putting their batteries everywhere, right? So even the mega packs that they're putting in, like I think in the California grid, so like they could just be a national utility eventually. I think Elon Musk has said like he wants to be, I think, the biggest utility or something like that.
Oh man, spoken like the words of someone who doesn't know what they're talking about. Maybe if no one has specific projects, I had a thought experiment that I've been trying to figure out. I don't know if anyone has thought about it this way. I always think of VPPs as peak shaving products. Like, okay, you're taking off that last high end, super expensive, or deferring like a peaker plant type of thing. But in my work recently, we're working on some innovation and resilience program funding, and I was thinking more about like as people start as distribution operators start thinking about deferring investments by implementing a VPP or a DER or a microgrid to say like, okay, instead of building a new transmission line or upgrading our system, we're going to add this thing here, and that's going to like add capacity when we need it. Is there a world where a VPP, where it could be a combination of different technologies and could be like a firm dispatchable resource where it could actually provide maybe not the full load needed or something, but it could provide load 24/7. Like maybe that's what EVs offer, or like behind the meter batteries. But I feel like I only ever hear VPPs about like being talked about as like, when the sun is shining and there's a heat wave or something, or peaker load. But is anyone thinking about VPPs as like a 24/7, or maybe I forget what the next tranche is, maybe like 18 or something, but like just as like a longer term resource throughout the day?
I mean, I feel like it could technically, right? If you have like 24 batteries of the exact same size, then you use one per hour.
Yeah.
And then
Or like a combination of technologies. Like I find myself thinking of a VPP as like an aggregation of one type of technology. Like this is a solar, this is a PV VPP, this is a V to G VPP. But like, if you really combine all those technologies, aren't you theoretically dipping into many different hours of the day? Like, if you have solar, if you have battery, you have vehicle, if you have thermostat, if you have heat pump water heater, like, couldn't you say, okay, with all these technologies combined and throughout the hours of the day, I can, control, like, let's say maybe 100 kilowatt hours, like each hour of the day, spreading it out or something like that.
I think Hawaii and Puerto Rico are close to that aspect of. I mean, see, if you scale up a microgrid, it essentially is a combination of DERs. And I think Hawaii has that rate making policy where they can incentivize customers to take up both solar and storage. And because of that, there's like a lot of storage around the island. So I think it's more about, is this going to work if it scales up? Because within a certain population size, it tends to work out really well. And obviously they are abundantly resourced in terms of like solar. They get like sun for pretty much the whole year. uh, but yeah, I think if you it for me, when I envision what do you call VPP, it's more like an upgraded or a large sized microgrid, because it does consist of a bunch of technologies, and the whole point is to like take less from the grid and give back excess, right? That's the working mechanism, I would think.
You're like, is there enough DER capacity that it could technically or theoretically cover all of the demand? And if so, then it's just a matter of like shifting it around.
I mean, that's the question, right?
We're lacking, right? Long-term storage. We've got decent short-term storage, but we still need storage that can hold capacities of days, right? That would be killer to get that.
Well, I think it's how much you can deploy at one time as well, right? Dispatch at one time, and it seems like there's this is just my opinion. My view is that there's varying levels of deployment that you can do here, and what everybody's been starting with is the demand response, because in that moment we kind of know that we can supply that much capacity in terms of demand response, just in reducing usage. And so in a sense, that's the easiest level to hit. And then it looks like what Tesla and other folks are doing with their next stage of the VPP is taking very specific times of day and saying we have enough capacity, whether it's via storage or any kind of actual generation, to supply a little sliver of electricity in that hour of the day. And then as capacity ramps up and as we get experience doing it with those small slivers, we're kind of validating the test case. And
Yeah, you're cutting out, Justin.
I just, it was getting good.
Wow. I have another question. Do you know how much solar? Oh, there we go. Just in your back.
Yeah.
How much solar are we wasting, if any? Like,
Residential solar?
yeah, just residential or utility, whatever is produced during the day. Is some of it just going to the dump, or lots?
Well, I don't think it's going to the dump. I just think it's not getting exported.
Yeah.
What do you mean?
Figuratively speaking.
It's
I mean,
there's a solar mopping. Basically, any spillage in solar gets used by some kind of tertiary resource, right? Otherwise, there's curtailment, which basically means not using that resource. So there is tons of it just because of the timing.
Did Ryan share?
What would community-sized geothermal storage look like, Rajiv?
Well, I mean, it's not geothermal essentially, but cities like I think Toronto downtown. It's basically the heating is based off of underground network, and that kind of sustains the heating supply for most of the winter months. And if it can work in Canada, I have my hopes up for other places as well. But yeah, that only works when it's dense and all the buildings and everything goes on in a close proximity, not like suburbia or something. But
Yeah, the built environment is a constraint. To plug my own employer, I don't. It's been going on for a while, but there's this program, I guess you would call it, called Connected Communities that DOE has been running. Yeah, some I've been following. I think they just did another award cycle, but they were kind of trying to show. I don't know if they were purposely trying to show like 24/7, but they're showing like grid interactive buildings. I think it's both like multifamily and single family homes. I remember like they were one was like a suburb in Georgia or Alabama where they were showing like if we aggregate this community, I think there was like solar smart thermostats. They were just looking at like actually at the community level having more than just yeah, I should find a report on that. But I think I remember being excited about the project when they announced it, and now they're already doing some other stuff. And my colleagues at INRAL tell me that commercial buildings have a lot of potential.
Or
Load flexibility.
And that load flexibility is mainly HVAC driven, right?
Yeah, HVAC and refrigeration. Yeah, but they have like such huge HVAC loads that like it's marginal to reduce it, and like but then you get like to thermal capacity of buildings, which is a battery, right? Like I mean, but a shitty battery sometimes, but still like a battery. If you can like store the heat or the cool in the building and just adjust it, it can make a difference to the grid. But I think it's not like energy in a box, like some people say, so it's harder to where like a battery is energy in a box. I don't know. I think for myself, I would be excited to see someone trying to make VPPs like a longer term, like a product that can happen throughout the day in a more reliable way.
even happen during the night.
Yeah, like a 24/7 product.
Yeah.
I have one question for you guys. So we earlier you guys were discussing how Tesla has this project ongoing, and it always seems like solar storage and EVs are the road towards VPPs. But I think HVAC has a huge potential. Like it's something that is already out there. It's just hard to connect because there's some like old equipment, and sometimes you require retrofitting. And so, what's the biggest challenge for someone like the bigger? I'm thinking of one of the global like Daikin or one of the global chiller plant suppliers in the world to build virtual power plants like Tesla is doing. If they already have access to the equipment, like they're the OEMs, right? So it's their equipment. They could potentially have visibility on how it's performing, even control it, perhaps. What do you see as the challenges there? Or ideas, if anyone has it.
Like why a thermostat manufacturer wouldn't become themselves like the VPP owner.
Yeah, and not a residential level, because I can see, I think Google Nest has done some testing there, but I'm thinking like big chillers, like big cooling plants, refrigeration at scale for commercial buildings. Like, why aren't those guys the ones who are trying to become the BPPs? Instead, someone's coming and installing additional hardware on top of their hardware to gain visibility of how it's performing, to later go and offer services to the grid. I keep wondering why it's not happening the other way around and trying to figure it out. But perhaps there are some ideas here.
So when you say HVAC, you mean for like reducing energy consumption, right?
Yeah, so I think about like shifting time of day use for HVAC systems without affecting comfort, which is what I'm reading here, right? So you could perhaps, if you know that you will dispatch in advance, it's demand response at scale. Like I still have a like a confusion between why is it a VPP or when is it a VPP and when is it demand response. I think it sort of fits the same purpose.
Yeah, it's just a different name.
Yeah.
I think why any OEM, whether they're making thermostats or they're making cars, why they don't get into the energy business is because it's a different vertical of expertise. Like when I when I learned about like managed charging, I was like, oh well, obviously like GM is just going to take over that market because like they're making the cars, they're making the chargers, like they'll just do all the managed charging. And then I talked to someone there and they're like, oh, absolutely not. Like we don't understand any of that stuff and like we don't want to build a whole business around it and like it's not benefiting like their bottom line because it's such an investment. So like an OEM doesn't want to get into that additional market. They don't even want to make the features sometimes. Like there's a lot of feedback still in my experience in the charging world between like an OEM making a charger and then people actually trying to have like an additional service on top of it. They're like, we need more APIs. We need like, I mean, I was working on compliance at PowerFlex and it was just like basic stuff. Like you can't sell your product here unless you do X, Y, and Z on the screen. And they're like, but we don't want to do that. Like, so I think it's just an OEM wants to make a widget and get it out the door in bulk and people adding service on that. That's their problem to solve.
Makes sense.
To add to that, I'd say that a lot of OEMs are wanting to become energy providers. It might be happening less on the HVAC side, but battery and EV charger manufacturers, anyone who has control over a battery is sort of starting to think of themselves as a energy provider. But maybe HVAC is like an older industry and not in that mindset yet.
Yeah, I think it's a good point. What's fascinating to me is that they currently represent perhaps 50% of the manageable load out there. So it seems like they have they should have an upper hand. And perhaps the challenge is enabling them, right? The APIs that you mentioned, like offering this as a service to them, like enabling them to generate this revenue. I know that there's companies like building similar things. And I guess that the challenges might be more on the integration to the energy markets everywhere. Like they have equipment everywhere in the world, and there's specific regulation for each place, and so I guess that might be like the bottleneck.
Yeah, I know. Like Ream, they have their own API for controlling devices, but they're one of those companies that is not opening it up. And my assumption is that the reason is because they're working on their own energy products. But I mean, their existing software sucks, so I'm not expecting very much of it.
I feel like vendors they are more focused on the controls aspect of things, so not really being part of a energy program or whatnot, but they are trying to use local variables or something like on-site data. It could be a solar, it could be wind, whatever temperature. They are trying to optimize for the indoor environment, which means they have scope to decrease energy, but from a local perspective, not really cutting down emissions from the grid side of things, like not being part of the program. They are doing their bit, but in a different way. Controls is like a touchy subject, right? So it will take some time.
Yeah.
Yeah. Do we know like the state of the world with storage? Are we limited by the technology or demand or just stuck in interconnection queues or maybe a combination of all three? for really helping scale up that, the potential for VPPs.
Don't we have like 4 years of interconnection queue or something?
Yeah, just wondering where's the stress point for just massive battery scaling. I was looking into like maybe storage as a service, and there are a bunch of companies, including Tesla, that are doing it. So
I guess that hardware deployment at scale just takes time. I think that it's growing, and there's like regulatory challenges in some places. Like overall, it's not as fast as we'd like, but I think it's moving on the right direction.
Yeah.
What is storage as a service?
Oh, like during the blackouts for where I live, it's like, I wish I had a power wall in my garage, right? And it's like, I want to fork out 11K. That's crazy. It'd be nice to say, just have Tesla install it for free, and I use it as a service, and don't have to incur that upfront initial costs. And there are some companies that are already doing that. So I don't know why. Maybe they're only offering it to like businesses, really big, not like small residentials.
And they just keep like any whatever incentive or market.
Yeah, I guess in the same spirit as Jigar's business model of providing solar as a service as well. So I thought that was
renting the asset, and then or I guess your rent is just letting them control it.
Yeah. So that homeowners don't have to incur that initial cost.
Interesting.
Yeah. But yeah, that's the $1 million question for me, is like, where's the soft spot to attack to really blow this up so we can get more business. I guess it's probably not a simple answer to that.
Yeah, I think it's all three in cost, just getting costs down. But the supply chain is a pretty tricky one. Like, so what I
Hey guys, can you hear me?
Yep.
I'm so sorry. I was just trying to talk something and felt like I was not heard. It was probably an issue with my headphones. Sorry about that. I joined the party pretty late. My name is Adesh Mehta. I work for Sonova Energy. So I have two comments. First is on the point of Alvaro about why HVAC's not being participating in the VPPs. I have thought a bit about it, honestly, like, having like a chemi head, you always think about that. So I feel the reason for that is the chillers that have been installed in past like couple of decades, they use refrigerant, and so refrigerant converts into like a cooling medium. So I mean, there is no like electrons that are being generated or being used. So to those legacy systems, it's going to be extremely difficult, like to have it connected back to the grid and then have electrons, like participate and help those actions. Mm-hmm. And similar thing even goes with the boilers, right? Like they either use oil, gas, and a few others. I mean, there are electric boilers that might have come up in the last few years, but the ones that have been installed for like years and years, we cannot really like unleash the potential of those assets because of that reason is my understanding. But probably like a few years from now, there could be like smart boilers or smart chillers that can have the capability to then participate and then have those standard communication medium that could help us interact with the grid.
Oh, so you mean like convert some of the heat into some kind of stored energy that can be translated back into electrons?
They may not convert from heat. Like there would be electric boilers. So instead of like boiler using that energy when they really don't need it, they might be sending it back to participate in the VPPs. That could be a possibility.
Oh, because I got to burn it anyway. Okay.
Yeah.
Oh, cool. That's
or
interesting. Yeah.
yeah, I mean, we could have like a compact storage device that converts or stores heat in the form of electricity. That could also be a thing. Um, so yeah, those were a couple comments on that. And then yeah, on the piece of like ownership of the assets, I mean, that's what I think Sanova's business is, where we offer leases and loans to the customers to install batteries, EV charging, EV chargers, panels on customer site for residential, especially. So, and I think if you're in California, we are offering free batteries right now. I mean, I'm not from sales, but the press release a couple of days ago.
And then from your perspective, what are the major barriers, right? Is just getting over apathy, getting just awareness out to the customer? What's the, from your perspective, what are the things that keep your company from hockey sticking up?
So in the residential side, if you ask, I think that there has been a decent traction of solar plus battery installation, and with the NEM 3.0, there have been extremely a lot of urgency that we saw from customers' point of view, where people really wanted to have the benefit of the 2.0 policy so that they could get better rates selling back to the grid. But secondly, I think with the storage technology, like we really need to understand that it's not making economical sense in all parts of the states.
Mm-hmm.
I mean, it's still like a luxury element where it's nice to have. And,
right.
It's good to have a battery, but it's not a must. But like if you see like parts like Florida or maybe like some parts of California which has TOU and those demand charges, that's the true value that you will see, that hey, then that shortens your ROI on the installation.
Maybe ironically, the more we neglect the grid infrastructure, the more the nice to have becomes a must have. if the power becomes more and more unreliable.
Absolutely. I mean, that's not something that we believe on. Like the grid is improving and we're gonna get more reliable power. We just see that the prices of the electricity is ridiculously going up year on year, and that's how I think this could be like a good hedging play for the end customers.
Mm-hmm. What about the interconnection queues? I looked at the CAISO's interconnection queues. It's just hugely backed up. Is that like a big impediment for, helping getting this scaled out? I mean, that's what I hear from reading articles and looking at the different queues. That's another key impediment because, it takes forever to evaluate it, and then there's situations where, oh no, you need to go and upgrade the distribution grid, and then who's going to pay for it? Just wondered if you had a perspective on that.
I think if you ask me, I mean, that's the process. I keep myself like at a 100-mile radius, at a 100-mile distance, I would say, because I don't really like how it's structured. And I think there could be a lot more people like me that the process is so cumbersome, it's so time consuming that it just like becomes one of the blockers. But in the resi space, I have not seen that as a significant challenge, honestly.
Okay.
It's much seamless and much faster, because of the digital tools that have been developed by the regulatory bodies. But in the CNI space, it's very, very painful. Like I've spent like most of my last few years in the CNI world, and the interconnection application takes like between like 3 to 6 months, and it significantly impact the timeline on the project completion date. So there probably is a need to come up with like a faster permitting process for CNI.
Hence the fun part of residentials. moves a lot faster.
Would it be faster to, instead of having one giant, how do they call that, like megapack somewhere, like 1,000 Powerwalls, utility scale? What if you just put them in 1,000 homes? Is that faster?
Yeah.
Like, I'm not sure who actually owns a utility scale. Like, does Tesla own that, or do they sell it to PG&E?
So in the world of deploying these DERs, there are multiple parties. So there are off takers. Like you would have project developers who would like to own and operate the assets, and they would use technologies like Tesla's or FlexGen or Pavin and those companies, and they will just be like a service provider over the life of the asset. So like the way that they make money is like selling the technology upfront, and having like a recurring O&M cost every year. So those are the two sources of revenue for them. Like technology companies will never own the assets in like 99% cases. And then there are like financiers, like Green was the company, like Green Tech. So there are like these infrastructure companies then who would invest, and then there will be like a engineering EPC company like Black & Witch who would do the engineering, procurement, construction work, and that's how the benefits will be. Like this folk, they will get the tax benefits out of that project, like the asset owners.
Right.
And in terms of utility scale, it has to be mostly the utility owns the asset in majority of the cases.
Yeah, it's amazing how much technology is only one small part of this whole ecosystem. Because when I first got into this, I had this naive idea that I'm sure everyone has, like, oh, let's build a open VPP platform that just busts open the market, and like dozens or hundreds of VPP companies can come in and actively participate and create a really dynamic energy market. But that's the reality is that's just not really practical, given all the other constraints and complexities of all the policies and all the regulations and all the different layers you got to deal with utilities and OEM vendors. So it's humbling.
I think I'd like to be optimistic. I think we are getting there. With have you heard of the smart home protocol? It's called Matter, and it's basically it's, I won't say designed, but it's something. It's a product that's come out of a bunch of manufacturers, including Apple and whatnot. It sounds like a failed experiment because it's been done before, but time I think the whole point of it is to like conserve energy using the devices that are already present. And it's something that can be packaged along with the device. It could be the smart thermostat, it could be the plugs, whatever smart something that you can find. I think they can all be controlled. And the best part I found is that it doesn't even require Wi-Fi. It uses a protocol that basically it's something like near field communication, but even if the Wi-Fi is down, you still have the devices kind of communicating to each other. It's not like breach of privacy when I talk like this, but I just meant like device standards and information exchange is getting probably easier in the near future.
Yeah.
And then talking about the device costs themselves, I think they are also decreasing. So at least from the residential point of view, it should be it should be a simpler process, I think. It should be like a whole home program rather than just saying an X utility would provide smart thermostat program. Nope. We'll provide like a whole home retrofit, and that includes a bunch of devices based on your affordability, right? So that makes more sense because then you're including the devices, and these are all high-end energy consumption, mostly like heating and water heating and whatnot, space heating. So that's what I envision. It's like a whole home approach rather than an individual component-based program that might enable or trigger VPPs.
Yeah, so you almost like a little VPP at your home, right? It would be cool if it had enough intelligence and there was enough protocol in place that each home would just dynamically communicate into the energy grid space, and just you don't have all these little centralized units like the utilities and the KISO, really, and all this like nonsense where a human being has to go and say, oh yeah, well, we think at this hour we need to go and get some power, so let's go and negotiate with a bunch of other people to get that power. I mean, come on, it seems like it's ridiculous. I mean, from my perspective, from an application perspective, from a cloud services perspective, it seems so ancient.
You won't believe, but
spreadsheets.
yeah. Like even we talk about heating systems and appliances and whatnot. So they are not even like regular, like they are not even appropriately sized when it comes to contractors interfacing with customers. So it's like when I'm supposed to install a 1 ton unit and I get 1.5 or even 2 tons, that's just unnecessary energy wastage. And then like the set points, it's something very basic, very fundamental, but that itself is programmed incorrectly, or some user overrides those things. So all these, like even at an individual or user level scale, it's things go wrong. So when you aggregate a bunch of wrong things,
Yeah.
what do you get? A bigger wrong. So
Yeah,
I'm
that's
just
bad.
like
Well,
thinking that's some fundamental issue.
if we're gonna talk like energy wastage, like leaving your windows open or doors open when like the AC or heat is on, especially like in New York buildings, like these old buildings where the building controls the heat, but you control your window. So you don't have a thermostat, but you just open your window even in the cold when they're pumping this heat into your apartment.
Yeah.
And this happens even in my apartment gym, actually. Like people just open the big windows because it's just hot in there with the heat going.
But
So that's
thermostat,
energy wasted.
the thermostat should have the smarts to know, okay, this is how much I believe it takes to heat up the unit. And if
Well,
you
I think we're
deviate
having two
that,
different conversations. We're talking like a perfect world versus the reality that we live in, and
no, I mean,
like devices are not smart and people are not smart.
no,
Sometimes.
I'm just saying in the future, you would imagine that a thermostat should have the smarts to look at the trend, look at how much it takes to heat your home, and if it sees deviation of that, be able to warn the
Oh yeah.
customer, hey,
I mean,
we
that's
think
what Nest is, right? Nest is
a
a smart thermostat. So yeah.
It's
And
just
going back to the
like my negative point of view or my jaded point of view is like
yeah.
utilities don't want to do energy savings because they make money by selling energy. And so like they have to be forced to do it. I think I need to read more about it, but the Hawaii Electric Company, so they actually changed their model instead of rate basing, which is like I build something and then I bill everyone for it. They're performance based standards now, and so that's like kind of a game changer in the like energy world, because instead of just saying like, well, I'm only going to build new things because that generates money and I'm only going to increase, it's kind of like a different way to a whole new paradigm of thinking about energy delivery.
On the IOUs compensated by capital improvements rather than rates?
Well, that's, I mean, it's capital improvements are what they rate base. So like that's what you, when you like file your rate case to say here's how much money I'm going to recover from customers, I'm going to charge, like it's capital improvements. There's a couple other categories, but like you don't get like rewarded for energy savings or for energy efficiency. Like you can't lump that into like your calculation of like how much money your regulated profit will be. So and it's just like a known tension of like utilities. You're like, well, utilities should go and upgrade and give everyone all these things that will give them resiliency, and they're like, yeah, but like the underlying thing is that lowers our profits. So there's just, I think there's innovation there to be had around like how can you incentivize a utility. I think like 80% of market. I don't know. There's a lot like utilities are still controlling a lot of energy delivery. It's not all just like ISOs and RTOs making this decision. So I think that could be it. And my office is working on it. So check back in a year, see what we're doing.
Has anyone like done a little like? Are there any research projects that said, okay, if I start a little city from the ground up, right, and I didn't have any utility companies or anything like that, what would be the ideal smart architecture and economic business model that would really, optimize the grid?
I think South Korea tried to build a smart city in like 2010, maybe. What'd you say?
In Colorado?
Oh yeah, the
That's not a good example.
yeah, there was one in Colorado that never got off the ground. It didn't like Sidewalk Lab tried to make a smart city that got shut down. South Korea, I think it was South Korea. They tried to make a smart city, like thinking about energy and mobility, and it also didn't really get far because privacy got in the way. I don't remember what the issue was with Excel. I think it was maybe money. I don't totally remember what, but it was privacy for Sidewalk and for South Korea because they were like, we're gonna scan everyone's face and you don't even have to have an ID. And people were like, absolutely not. But also it's hard. Like it's hard to have that infrastructure. I think we don't even have that much technology.
It's almost like too much centralization. It's like not going to work in a capitalistic society. It may work in a communist society, but it's a different conversation.
The privacy question is a really good one. Is there a way we can provide the information but somehow obfuscate it at such a level that you feel that your information is relatively private? I don't know.
Yeah.
That's hard.
Yeah.
Because again, like people don't understand energy. They definitely don't understand like technology privacy. Like, people don't like smart thermostats. They don't like 5G. Like, maybe a lot more. Actually, it's been fun chatting with y'all again, and I don't know what the next topic will be, but I'll be here for the next call when y'all. One. Thanks, Ben, for organizing.
Thanks for suggesting.
Thanks, Kristen. Thanks, Ben.
All right, thanks, guys. See ya.
See ya.
All right, guys. Bye-bye.
Nice talking to you.
Thank you.